I'm Mrs. Gauri Manohari, Assistant Professor, Department of Science and Humanities, Nehru Institute of Technology. So today we're going to discuss characteristic equation and eigenvalues and eigenvectors in the course Matrices and Calculus. And the subject code of the course is MA 3151. So first we're going to see the object of the courses. That is nothing to learn the definition of eigenvector and eigenvalues. So the next objective is nothing but to develop the use of matrix algebra techniques that is needed by engineering for practical applications. Next we enter to the topics. So characteristic equation, without knowing the characteristic equation, we are not able to discuss eigenvalues and the eigenvector. So first of all, we start to discuss what is characteristic equation. Next we move to eigenvalue and eigenvector. So characteristic equation is nothing. We consider a matrix A, let A be a given matrix and lambda be a scalar. Then the characteristic equation we defined as determinant of A minus lambda I equal to 0. So if we start to solve this equation, we're going to get a characteristic equation. For example, we consider 2 by 2 matrix and we are getting the characteristic equation only quadratic form. That is nothing but lambda square minus S1 lambda plus S2 equal to 0. Where S1 is nothing, we're going to apply the formula sum of main diagonal and S2 is nothing, determinant of A. Suppose we're going to get a 3 by 3 matrices. At that time, we're going to get the characteristic equation is nothing. S lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So here S1 is as usual, we're going to find out sum of main diagonal and S2 is sum of the matrix of the main diagonal and S3 is determinant of A. So additionally only one thing we're going to find out, S2 is sum of the matrix of the main diagonal. So we're going to see one example. So see this example. So here we are going to get a 2 by 2 matrices. If A equal to 1, minus 1, 0 and 1. So already I explained, we are getting 2 by 2 matrices. Surely we get the characteristic equation is quadratic equation. So if we apply the condition determinant of A minus lambda equal to 0, A in this place of A we consider the given matrix A 1, minus 1, 0 and 1 and lambda is nothing scalar. Consider like a variable and I is nothing identity matrix. So if you apply the condition, so we will get it 1 minus lambda minus 1 0 1 minus lambda equal to 0. So we just cross multiple, that is nothing, we find out the determinant value, automatically we are getting the characteristic equation lambda square minus 2 lambda plus 1 equal to 0. So if the matrix is 2, surely we are going to get it 2 by 2 quadratic equation. If the matrix is 3, we are going to get it cubic equation. So next example is we consider the matrix as 3 by 3 format. So at that time, end of the equation we get a cubic equation. If the order is 4, it's gradually going on. So next we start to discuss eigenvalue. So what is eigenvalue? Eigenvalue is nothing, the value of lambda in a characteristic equation. We find out the scalar variable value, that is lambda. We start to find out that lambda value only we going to declare as a eigenvalue. So by the definition wise we go through it. The value of lambda obtained from the characteristic equation determinant of A minus lambda equal to 0th condition are called the eigenvalue of A. So this is eigenvalue. We're going to check it. Next is eigenvector. So eigenvector is nothing. Let A be a square matrix. If we want to find out the eigenvector, surely the A must be square matrix. So let A be a square matrix of order n and lambda be a scalar, x be a non-zero column vector such that Ax equal to lambda x. We start to execute Ax equal to lambda x. At the time only we are going to get the eigenvector. In that condition we find out the x value. That x value only we are going to declare as an eigenvector. This is a procedure. Now in problem wise we start to discuss, that is we start to calculate eigenvalue and the eigenvector. So first example. find the eigenvalue and eigenvector of a matrix. So the given matrix has 3 by 3 matrix. So if the matrix has 3 by 3, we're going to get it 3 by 3 matrix characteristic equation as a cubic equation. With the help of the cubic equation only, we can find out the eigenvalue and eigenvector. So first of all, we start to find out characteristic equation. So how we find out the characteristic equation? By using the condition determinant of a minus lambda equal to 0. With the help of the condition only, we can find out the characteristic equation. So here in that equation already we know that lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. S1 is nothing, sum of the main diagonal. So in that matrix, main diagonal position has nothing, a11, a22, a33. a11 is nothing 2, a22 is nothing 1, and a33 is nothing minus 3. So if you add it, you're going to get sum of the main diagonal. So 2 plus 1 minus 3 equal to 0, that is your S1 value. Next we start to calculate sum S2, that is nothing, sum of minus of the main diagonal. So we consider the main diagonal. For that we find out the minor value of the diagonals element. So first main diagonal is nothing, a11. So we consider a11. So corresponding row and column we leave it. Remaining element we collected and we frame the determinant and we calculate. We may get the answer for overall S2 is nothing, minus 13. Similarly, we consider second main diagonal is A22, that is 1, and third main diagonal is nothing, minus 3. So final S2 is nothing, minus 13. Next we start to calculate S3. S3 is nothing, we know the very well formula, S3 equal to determinant of A. So we start to calculate the determinant value of a given matrix. So we may get it S3 is nothing, minus 12. So next step we start to find out all known value, that is S1, S2, S3 in a standard characteristic equation. If you start to apply, you are getting the equation as lambda cube, that is S1 is default as 1 and S2 is minus 13. So we substitute, we may get it minus 13 lambda, S3 equal to minus 12. So negative into negative positive. So we will get it plus 12. So the overall characteristic equation is lambda cube minus 13 lambda plus 12 equal to 0. So step 1 over. Next we start to find out the eigenvalue. So eigenvalue is nothing. In that characteristic equation, we find out the lambda value, that is called it as a eigenvalue. So next we start to find out the eigenvalue with the help of the synthetic division procedure, because quadratic equation mean by apply the formula wise we can find out, but it is a cubic equation. With the help of the synthetic division procedure only we can find out. So now we start how we apply the synthetic division procedure. We collect the all coefficient of the variable and we frame the detail. So lambda cube coefficient is 1, lambda coefficient is minus 13, and constant value is 12. In this equation lambda square is not available, so we consider lambda square coefficient as 0. So first we frame the synthetic division condition, synthetic division notation, and 1 0 minus 3 12. So next we are going to choose the division value. So first we choose it as 1. So we start to divide and we are getting the equation. The main purpose for using the synthetic division, we split the equation, we reduce the degree value, cubic to quadratic. So we applied the division procedure and we are getting the reducible format or reducible equation as lambda square plus lambda minus 12 equal to 0. So now cubic equation to quadratic manner we converted. Next in a quadratic equation we applied the very well formula, that is nothing, minus b plus or minus square root of b square minus 4ac divided by 2a. We applied the formula and we find out the lambda detail, that lambda value only we are going to declare as a eigenvalue. So here we applied the formula minus b plus or minus square root of b square minus 4ac divided by 2a. And here a is nothing 1 and b is nothing 1 and c is minus 12. If you apply simplified, you are getting the lambda value as 1 comma 3 comma minus 4. So eigenvalues of the given matrix is 1 comma 3 comma minus 4. Next we start to find out the eigenvector. So already we know very well the condition, eigenvector is ax equal to lambda x or a minus lambda into x equal to 0. So here we substitute the x variable detail. If you are giving the matrix detail as 3 by 3, we are going to declare 3 variable. If the matrix order as 2, we are going to declare the 2 variable. If the matrix order is 3, so here we are going to declare the 3 variable, capital X equal to x1, x2, x3. Always we write the variable in a column wise, because in matrix row into column only possible, so we should declare declare the variable in a column wise. So x equal to x1, x2 and x3. So now we start to find out the eigenvector with the help of the condition a minus lambda x equal to 0. A is nothing given matrix, and first we applied a minus lambda I. So a minus lambda is nothing, 2 minus lambda I is identity matrix, lambda is scalar. So directly we return the condition. So 2 minus lambda 2 0, 2 1 minus lambda 1 minus 7 2 minus 3 minus lambda. With that we are going to multiply the eigenvector variable, that is nothing but x1, x2, x3. So here we are going to get the normal matrix multiplication, that is row into column. So first row 2 minus lambda 2 0 into x1, x2, x3. So we are getting the equation, first equation as 2x1 plus 1 minus lambda into x2 plus x3 equal to 0. So next second row into same variable. So we may get the equation as 7x1 plus 2x2 plus minus 3 minus lambda into x3 equal to 0. So next third equation, we may get it as minus 7x1 plus 2x2 minus 4 lambda x3 equal to 0. So in the case 1, first we consider the first eigenvalue. So already we find out the eigenvalues are nothing 1 3 minus lambda. So in a minus lambda x equal to 0th equation, in case 1 we choose the first lambda value, that is nothing 1. In second case we choose the second lambda value, that is 3. Third case we choose the third lambda value, that is nothing minus 4. So first we start to choosing lambda equal to 1, case 1. So we substitute in the previous equation, we substitute as lambda equal to 1. So we simplified the equation. Then we start to solve the equation. We are going to get it the 3 variable x1, x2 and x3. So first we substitute lambda equal to 1. So we will get it x1 plus 2x2 plus 0x3 equal to 0. Second equation 2x1 plus 0x2 plus x3 equal to 0. And the third one is minus 7x1 plus 2x2 plus of minus 4x3 equal to 0. So in this how we going to solve the equation mean the cross rule method only we can solve the equation, because if the 2 equation mean we use the solving by 2 equation procedure, within a step we are getting the answer, but 3 equation we get it because the matrix are 3 by 3. So we only the cross rule method we used and we are going to find out. So in these 3 equation you may consider any 2 equation 1 and 2 or 2 and 3 or 3 and 1. So if you choose any 2 equation, surely you are going to get the same eigenvector. So here I start to consider equation 1 and 2. So equation 1, x1 coefficient as 1 and x2 coefficient as 2 and x3 coefficient as 0. So now we start to consider, and next we consider the x1 coefficient as 2, x2 coefficient as 3 and x3 is 1. So we consider, if you want to find out the x1 variable, we leave the x1 column, remaining you want to consider, that is 2 0 minus 1, and x2 mean we leave the x2 variable column, remaining we consider. In that way we by apply the cross rule method we are getting x1 equal to 2k, x2 equal to minus k and x3 equal to 4k, and we consider k is nothing 1. So we will get the final vector is the first set of vector is x1 is nothing 2 minus 1 and minus 4. In that way we choosing lambda equal to 3, case 2, and we are getting the vector is nothing x2 vector is 2 1 and minus 2, and we consider the third case lambda equal to minus 4. At that case we are getting the third set of vector 1 minus 3 and 13. So this is the procedure. So what is the outcome of the eigenvector is nothing. Eigenvalues and eigenvector allow us to reduce the linear operation to separate simple problem. That is the main outcome of the eigenvalues and eigenvector. And the next one is the application of eigenvalue and eigenvector is useful for the decoupling three-phase system through symmetrical component transformation. So what is the practical application of this topic mean? Eigenvalue analysis is also used in the design of the car stereo system, where it helps to reduce the vibration of the car due to the music at the time. Okay. Thank you.